Welcome to the notes for Mrs. Neller's pre-calculus class. These are the notes for section 3.7, day 3, entitled Rational Functions. And today we're going to talk about one more characteristic of the rational functions, and that is the slant asymptote. And basically, a rational function that has a degree of the numerator that's one more than the degree of the denominator can be divided using either long or synthetic division. And what that is going to tell us is basically going to be the slant asymptote. So after we do that division, we're going to take part of our answer and put it into the form y equals mx plus b, basically, slope-intercept form, and that line then becomes our slant asymptote. Sometimes that's also called an oblique asymptote because it's kind of slanted to the side. That's what oblique means, but we're going to call it a slant asymptote. So this you have to do when the numerator is 1 degree larger than the denominator. So that would be like x squared over x, or x to the 10th over x to the 9th. Now you don't have to do this if it's like x to the 10th over x to the 5th. Okay, that's a bigger difference than just 1. So this is only when the degree of the numerator is 1 more than the denominator. Okay, so we have just a couple examples to go through so that you can practice this concept. And again, we're going to go through all the steps that we've done in our previous notes. We're going to factor, we're going to find our x and y intercepts, our horizontal and vertical asymptotes, then our slant asymptote, if we have one, and then we'll do our graph. So this is just one more step that you may or may not have to add in depending on the degree of the numerator and denominator. So if we look at our example here, our numerator is x squared and our denominator is x. So that's going to tell you that yes, there's 1 degree difference in our numerator to our denominator. So that means we are going to have a slant asymptote. And it also tells us a couple other things, okay? But first, let's do this first step. Let's do our factoring. So in my numerator, I have a trinomial. So I'm going to do guess and check. Got x and x, and then I need the factors of 5. That'll get me to a 4. Well, that's got to be a 5 and a 1. And I need it to add to a negative 4. So I need the 5 to be negative and the 1 to be positive. And then in my denominator, I'll just leave it x minus 3. Can't do anything to simplify that. Now again, nothing's going to cancel here. That's okay. But having it in this factored form is going to help us find our vertical asymptote in a moment. Okay? So next I'm going to find my x-intercept and my y-intercept. Okay, remember your y-intercept is when you plug in 0 for x. So basically I would have 0 squared is 0, minus 4 times 0 is 0, minus 5, and then 0 minus 3. So basically I get a negative 5 over a negative 3, which is 5 over 3. Okay. Now you can think of it like that, or you can think of it as 1 2/3. That might be a little easier to think of it as 1 2/3 when you're actually graphing it, but you can leave it as an improper fraction. My x-intercepts then, remember this is basically what makes the numerator 0. So you're going to set the numerator equal to 0. So the two pieces I had in my numerator when I factored it were x minus 5 and x plus 1. So then I'll get x equals 5 and x equals negative 1 when I solve those. So those would be my two values that would make my numerator 0. So those are going to be my x-intercepts. Now remember, there's a connection between our x and y intercepts and our horizontal and vertical asymptotes, okay? But we'll just focus on the horizontal asymptote for now. Remember, for the horizontal asymptote, we have three characteristics. Okay? If the numerator is equal to the denominator, then you write a ratio of the lead coefficients. I don't have that. Okay? The degree of my numerator is 2, the degree of my denominator is 1. They're not equal, so I don't want a ratio. If the degree of the numerator is less than my degree of the denominator, then it's just automatically y equals 0. I don't have that either. I have the third case where the degree of my numerator is greater than the degree of my denominator. So in this case, I have no horizontal asymptote. Okay? So that's usually going to happen when you have a slant asymptote. Okay? The vertical asymptote now, remember this is what makes the denominator equal to 0. So my denominator was x minus 3. So if I set that equal to 0 and solve, then I get 3. So that's going to be my vertical asymptote. Okay. Now, I'm not going to worry so much about the behavior near the vertical asymptote. We're going to discover that as we do some test points. But remember, your book is going to say that as you approach the 3 from the left, the y is going to actually go towards positive infinity. So you're going to get some positive numbers. And as you approach 3 from the right, then y is going to go to negative infinity. That's what the book's going to say. But those are the values that we're going to get when we test a couple points. Okay, now, because I didn't have a horizontal asymptote, and because the degree of my numerator is 1 more than the degree of my denominator, I know I'm going to have a slant asymptote. So this is where I need to do either synthetic division or long division. I think it's better to do long division. I think long division is just done more traditionally with this type of a problem. So we're going to have x squared minus 4x minus 5, which is my numerator. I'm actually going to divide it out with my denominator, x minus 3. So again, ask yourself, what times x is x squared? That's an x. And then you distribute. So I get x squared minus 3x. Remember, you have to subtract both of those. So the x's or the x squareds cancel. And then I get a negative 1x, and I bring down the minus 5. And then x times what is negative 1x? Well, that's a minus 1. And then I distribute. So I get negative 1x plus 3, and then I subtract those. Those are going to cancel, and then I get a negative 8. Now, the negative 8 is going to be my remainder. And really, I'm not worried about the remainder so much at all. I'm really just worried about my first two terms here, the x and the minus 1. And once I have that, then I'm going to write the equation for my slant asymptote. Y equals x minus 1. And it's going to be in slope-intercept form. Okay. Now you could do this with synthetic division as well. If we wanted to do synthetic division, remember you put the opposite signed number in the little box, and then your lead coefficients. And you bring down the 1, and then you multiply, and you add down the columns. Then you multiply, and then you add. So that last number is your remainder. So then you know that you get 1 degree less, so you get x to the first minus 1. Okay, so then that whole part of your answer, everything but the remainder, we're not using the remainder, so everything but the remainder would become your equation. So you could do this with either synthetic or long division. Remember, you can only do synthetic division when you're dividing by a binomial, though. So if you have a trinomial divided by a trinomial, then you have to do the long division. Okay. So then to graph, first things I'm going to put in are going to be my axes. Let me use blue for that. Let me put my axes in, and then I'm going to put in my horizontal and my vertical asymptotes and my slant asymptotes. Okay, so there's my axes. And then let's see, my horizontal asymptote, I didn't have any. Good, that's easy to graph. And then my vertical asymptote is x equals 3, so 1, 2, 3. Again, make them a dashed line. And then my slant asymptote is going to be good old slope-intercept form. So I'm going to start at negative 1, and I go up 1 and over 1, or down 1 and back 1. Okay, so plot a few points so you can see where that line goes, and then just connect them with the dashed line. Okay. So now I'm going to test a couple of points to see where my graph is actually supposed to go. I'm going to test some points to the left and to the right of my vertical asymptote. So I want to pick some numbers that are less than 3 and some numbers that are greater than 3. So again, you don't really have to do a complete table of values here, but if it helps, you can test the points 2 and 1 and 0. Those are some values less than 3. And then you could do 4 and 5, maybe even 6 if you wanted to. And again, I'm not so much concerned as to what the actual value is that I get out. It's more of where the location is of it. But if it helps you to write down the actual points and then plot them, then you'll get the actual location. Okay? And remember, we do have our x-intercept and our y-intercepts as well that we can plot. So my x-intercept, let's see, I had one of them at -1, and the other one was at 5. And then my y-intercept was at 1 2/3, so right about there. So already I can see that part of my graph, my values that are less than 3, my x values that are less than 3, are all going to put me in this region that's above my slant asymptote. So my curve here has to go through those 2 points, and then I can just kind of estimate where the rest of it is. Okay, so basically, again, I'm not real worried about what those values are. You just need to know that it's going to get you a point that's above the slant asymptote. And then for the values that are greater than 3, already I can see that I've got 1 here that's below my slant asymptote. And if I pick some more, that would still happen. I get all these values that are going to be below my slant asymptote. So this part of the graph is going to curve like that. Okay, so anything that's above 3 is going to be below the slant asymptote. Okay. So I know I'm purposely not writing in those values. If you want to write them in, that's fine. The book has them listed, and if that helps you plot the points, by all means, that's okay. The last thing we have to do then is write down our domain and our range. So the domain, again, is going to be all of our x values except for any vertical asymptotes. So it'll be all of the x's except for 3. And then my range, I'm not really limited in my y values at all here. I'm going all the way up to positive infinity and then all the way down towards negative infinity. So I'm going to end up with all real numbers there for my range. Okay, so there's the book picture, and there again, they complete their table of values and have those values listed for you. Okay, and we're going to take a look at one more example. This one's just a little more complicated. Again, this is where you can't do synthetic division with this polynomial when you're trying to find your slant. Okay. Now I can go through this one and I can complete it. Depending on how we feel in class, this may or may not be an example that we cover in class since it says extra example, but I will complete it here so that you can watch this and review. So the very first thing we have to do is we have to factor our numerator and denominator. So let's see, in my numerator, I'm going to have to take out a greatest common factor. So I'm going to have to take out the x, and then I'll have x squared minus 2x minus 8. And then I will have to factor that as well. I need the factors of 8. That'll get me to 2. So I'm going to leave the x out for my GCF, and then I'll have my 2 sets of parentheses for the guess and check. So the factors of 8, that'll get me to 2. That's going to be a 4 and a 2. And it has to be a -4 and a +2 if I want to get to a -2 there. And then in my denominator, let's see, I have the x squared minus 2x minus 3. That I can do with guess and check. So I have an x and an x. And then the factors of 3 that get me to 2, that'll be a 3 and a 1. I need it to get to a negative 3, so I need the 3 to be negative and the 1 to be positive. So there's my factored form of my function. Okay, so this one's a little trickier because you have to take out the GCF in the numerator and then do guess and check. So it's a two-step factoring in the numerator. Okay, my y-intercept, if I plug 0 in for x, if I plug 0 in for x everywhere in my numerator, I end up getting 0 over negative 3. So that's just going to be 0. And then for my x-intercept, remember those are the values that make your numerators 0. So my x-intercept is going to be 0 and negative 2 and 4. And then the degree of my numerator is 1 more than the degree of my denominator. So I don't have a horizontal asymptote. And my vertical asymptotes are going to be the values that make the denominator 0. So that I can see clearly in the factored form here. So those will be x equals 3 and negative 1. And then the end behavior, we'll figure that all out once we do some test points. But I also have to figure out my slant asymptote. And this is going to take a little bit of work with our synthetic division. So let's see if I can squeeze it in here. I'm going to have x squared minus 2x minus 3, and that's divided into x to the third minus 2x squared minus 8x. Now, technically, I need a placeholder there at the end because I'm missing that constant term. So I'm going to put in a plus 0. So that's one thing that you have to remember with your synthetic or your long division is that you have to put in your placeholders. So to go from x squared to x to the third, I need to multiply by x, and then I distribute to all three of these terms. So I've got the x to the third minus 2x squared minus 3x. And I'm going to subtract. So the x to the thirds are gone, and the x squareds are gone. So I end up with minus 5x, and then plus 0. Now I could keep going, really, but this is going to be my remainder. Okay, so I don't have to concern myself with that. Really, I just need this part here, the x. So my slant asymptote is going to be y equals x. So that's like y equals 1x plus 0, if you want to think of it in slope-intercept form. Okay, so then I'll put in my axes so that I can graph. And then I'll switch my colors here so that I can put in my asymptotes. Okay, my first asymptote is the horizontal one, which there wasn't one, so I don't have to graph that. My verticals are going to be at negative 1 and 3. 1, 2, 3. And then my slant asymptote is going to start at 0, 0, and it's going to go up 1 and over 1. And then down 1 and back 1. Okay, so now that I have those, I can do some test points to figure out where my graph's going to go. I want to pick some values that are to the left of negative 1. So I'd want to pick negative 2, negative 3, maybe negative 4. And I'm going to see there. Oh, wait a second. I also have my x and y intercepts. Let me plug those in. I've got my negative 2 and my 0 and my 4. Okay. And then my y-intercept is 0. Okay. So here again, because of the intercept, I can see that this part of my graph, any of these values that I pick going towards negative infinity, I'm going to stay above that slant asymptote. So my graph is going to kind of curve like this. Okay. For that middle region, there's a couple different shapes. I could get a U that stays up at the top. I could get a U that stays at the bottom. But since I'm crossing my actual slant asymptote here, I'm probably going to have some kind of little zigzag action going on. So you could test like -1/2, and that's going to get you a negative value or a value that's below your slant. And then if you pick values like 1 and 2, you're going to get values that are above your slant asymptote. So this part of the region has a curve in it like that. So it kind of looks like an x to the third type of a graph. And then the other region we have to test is going to be to the right of x equals 3. So you want to pick 4, 5, 6, etc. And already from our intercept, you can see that these values are all going to be below the slant asymptote. So this part of the graph is going to look something like this. Okay. So then again, we could write down our domain, which would be all of the x's except for -1 and 3. I put the comma in the wrong spot there. And then our range is actually going to be all real numbers because we do incorporate all values on the y-axis. And we cross our slant asymptote here. So this middle part of the region really shows that we're using the whole y-axis and all of those values in our graph. So I know it's a lot of information on one slide, but again, this is review. This is a more challenging problem. So if you can follow through this or redo this one on your own, understand it, you feel good about the information and where all those concepts are coming from, then you'll be in good shape for a quiz and a test. Okay, so these are your homework problems for this evening so that you can practice these concepts. And again, it's more practice of synthetic and long division. So if you weren't real strong with that, now's your chance to practice that again and get better at that so it will help you to find your slant asymptote. Remember, I have all the solutions worked out in the binder in my classroom, and if you have any questions, come on in and see me before school.